Hello, in this video, I'll be presenting our MPMC project titled Ultrasonic-Based Obstacle Detection and Indication System with AT51. At the heart of this project is the aryabhatta dev board, which uses the classic AT89S52 microcontroller. The eyes of the project are these two HC SR04 ultrasonic sensors. They work by sending out a high-frequency sound wave and listening for its echo. The microcontroller measures the time it takes for the echo to return and calculates the distance to an object. Alongside these components, we are using a 9-volt battery, LEDs, and transistors. The core idea is simple. Where we have two ultrasonic sensors. When sensor 1 detects an object, the first LED lights up. When sensor 2 detects an object, the second LED lights up. Now, the microcontroller's output pins can't provide enough current to power an LED brightly, especially when we have other components to run. This is where the transistor comes in. Think of each transistor as an electronic switch. The microcontroller sends this 5-volt signal to the transistor base. This turns on the transistor, allowing a much larger current to flow from our power source to the LED, making it glow brightly. Speaking of power, all these components need a stable 5 volts to operate. I'm using a 9-volt battery as the main power source. The dev board has a built-in voltage regulator. This crucial component takes the raw 9 volts from the battery and steps it down to a clean, steady 5 volts, which is then used to power the microcontroller, the sensors, and our transistor LED circuits. Now on to the hardware connection. Starting with the ultrasonic sensor, sensor 1's trigger pin connects to P2.0 and its echo pin to P2.1 of the dev board. Similarly for sensor 2, its trigger pin is connected to P2.2 and echo to P2.3. Both sensors receive 5 volt power and ground connections from the board. Now LED 1 is controlled through pin P1.0, which connects to the first transistor base to a 1 kΩ resistor. Similarly for LED 2, it's controlled through P1.1 to connect to the second transistor through a 1 kΩ resistor. Each LED gets power directly from the 5 volt rail through a 270 ohm current limiting resistor, with the LED cathode connected to the transistor collector and the emitter connected to the ground. Now this program creates an intelligent object detection system. It continuously monitors two ultrasonic sensors in a loop, sending sound pulses and measuring echo return times to calculate distances. When an object comes within 3 to 10 centimeters of either object, the code instantly lights the corresponding LED. The system includes protective delays between sensors and readings to prevent interference, ensuring reliable and accurate detection. Now we have coded our entire project in C. So first we build and rebuild our saved code, which creates a hex file. Now we open our program ISP programmer, which is how we load our code into the microcontroller. Now in this ISP programmer, first we go to the top left and select our chip, which is AT89S52. After we select our chip, the first thing we have to do is erase. Then we load our hex file into the ISP programmer and click auto, which again erases, verifies, and loads the flash into the microcontroller, which means the code is loaded into the microcontroller. So once the code is loaded, there's no longer any need for the laptop. The code, once as long as the microcontroller has power, the code continuously runs. We are using this cable to connect the laptop and the 84 microcontroller such that we can flash the file onto the microcontroller. This also gives power to the microcontroller.